Good morning, students. Yesterday, I explained first shifting theorem, how to apply first shifting theorem to the problems. So, once I explained the statement of the first shifting theorem, then go to today topic. The main statement of the first shifting theorem is L of e power at into f of t equal to f bar of s as s tends to the quotient of a in the exponential function t, that is plus a. So we write the opposite sign, that is minus a. So s tends to s minus a, that equal to f bar of s minus a. In the given problem, suppose e power minus at exists. So we write the reverse of the minus a. So we write the opposite sign of the coefficient of t, that equal to minus a to plus a. So replace s by s plus a. Finally, a bar of s plus a. This is the condition of the first shifting theorem. So many problems I explained in last class. So now today topic is first we discussed two or three definitions, important definitions. Then we go to how to apply the multiplication of t power n, how to apply the integral of Laplace transform, and division by t. These three topics next we discuss. So first I explain the definition of unit step function. So observe that in the screen, the unit step function is defined as h of t minus a. Unit step function is another name is Heaviside unit function. General name is unit step function and another name is Heaviside unit function. That's why u of t minus a or h of t minus a is the denotation. Here unit step function defines in two ways. One is h of t minus a. H means Heaviside unit step functions or are u of t minus a. Here u means unit step function. So both defines are equal. Now the unit step function is defined h of t minus a. H means Heavisides or u of t minus a. U means unit step, equal to, it splittings into two values, 0 if t less than a and again 0 if t greater than a. Okay, this is the unit step function at t equal to a. So the unit step function cutted the values of at t. So simply 0 to infinity is the range. So we discontinued the range 0 to infinity by a. So the total continuous value 0 to infinity, now we discontinue at a, it is converted to 0 to a plus a to infinity. Then Laplace transform of u of t minus a is defined as integral 0 to infinity e power minus st u of t minus a into dt. How to write? We know that L of f of t equal to the definition of Laplace transform integral 0 to infinity e power minus at f of t dt. So replace left hand side function f of t in the integration. So f of t dt. In similar way, L of u of t minus a L of u of t minus a is also written as integral 0 to infinity e power minus at e power minus at. Here f of t is u of t minus a. U of t minus a into dt. So the function Laplace function f of t is replaced by u of t minus a. That is integral 0 to infinity e power minus s to u of t minus a into dt. Simplify the equation and substituting the limits, we are getting the answer e power minus s by s. So finally, Laplace transform of unit step function, it is denoted by u of t minus a as defined by e power minus as by s. Okay, this is the formula of unit step function. What is the formula of unit step function? U of t minus a is defined as 0 to 0 comma if t less than a, and again 0 if t greater than a. Simply in 0 to infinity range we disconnect the point at a, then 0 to a is 0 and a to infinity is also 0. Then applying the Laplace of unit step function L of t minus a, we getting the result e power minus s by s. It is very very important definition. It only definition only. Then go to second definition. Yesterday I explained first shifting theorem or first translation theorem. Here also two names, first shifting or first translation, and apply to the problems. So this is the second translation or second shifting theorem. First shifting, first translation theorem is very important for the solving problem. Second translation and the second shifting theorem is important only for definition wise. So what is the statement of second translation or second shifting theorem? Observe that L of f of t equal to f bar of s, L of f of t equal to f bar of s, and a defined g of t, another function, in two properties are completed. First one is linearity property and second one is first shifting theorem. These two functions are in discussing only single function f of t. Here another function is also available, that is g of t. Here that g of t is defined as discontinuity function. So g of t is discontinuity. So f of t minus a as t greater than a and 0 t less than a. That means in the range 0 to infinity, we disconnect the range at a. So in the range 0 to a, the function g of t is f of t minus a. In the range a to infinity, the g of t is 0. So total range is 0 to infinity. In the continuity, we disconnected point a. So 0 to a is g of t is f of t minus a, and a to infinity g of t is 0. Then we applying, hello, my voice clarity on the voice interesting the clarity ga clarity ga unna.
Sir, clarity sir.
Okay, so g of t is defined by f of t minus a comma t greater than a, 0 t less than a. So how to define? First we take the complete range of the g of t. The g of t range starts with 0 and ends with infinity. T greater than a. So t value a కంటే ఎక్కువ ఉంటే, so here f of t minus a, and t less than a కంటే తక్కువ ఉంటే, so it reaches 0, then g of t equal to 0. So 0 to infinity range, this is the t less than a అంటే ఏ కంటే తక్కువ అయినప్పుడు ఏకి లెఫ్ట్ సైడ్ దిస్ ఈజ్ టీ గ్రేటర్ దెన్ ఏ కంటే ఎక్కువ ఉన్నప్పుడు అంటే ఏకి రైట్ సైడ్ ఉండాలి. సో దెన్ we applying the Laplace transform of g of t, we getting the result e power minus as by f bar of s. Here proof is also available. If you have interest, we do the proof. మీకు ఇంట్రెస్ట్ ఉంటే ప్రూఫ్ కూడా నేర్చుకోండి. మన సిలబస్ లో ప్రూఫ్ అయితే అవసరం లేదు. I explain one problem of the second shifting theorem. So that is find Laplace transform of g of t. Find Laplace transform of g of t. Here defined g of t equal to cos of t minus pi by 3 if t greater than pi by 3 and 0 if t less than pi by 3. Observe that in general definition of g of t is defined in second shifting theorem. G of t equal to f of t minus a if t greater than a. So observe that the point of a is given pi by 3 in the problem. In the definition a, in the problem pi by 3. So comparing both definition and problem, we taking a value as pi by 3. So clearly here a equal to pi by 3. And f of t minus a value equal to cos of t minus pi by 3. Recently we write a equal to pi by 3. So remove a and pi by 3 and remaining function f of t equal to cos t. F of t equal to cos t. Apply Laplace on both sides. L of f of t equal to L of cos t. We know that the second trigonometric formula L of cos at s by s square plus a square. S by s square plus a square means here a value 1. So s by s square plus 1 is f bar of s. What is the statement of second shifting theorem? L of g of t equal to e power minus as into f bar of s. So e power minus as, e power minus a means here a equal to pi by 3. Pi by 3 into s. L of g of t equal to e power minus as into f bar of s. So e power minus pi by 3 into s, f bar of s, s by s square plus 1. So e power minus pi s by 3 into multiplying numerators. So s into e power minus pi s by 3 divided by s square plus 1 is the L of g of t. I explain once how to apply the second shifting theorem to the given problem. The given problem g of t like as the statement of second shifting theorem condition. So what is the statement of second shifting theorem? In the second shifting theorem is defined as g of t function. This g of t function is defined two discontinuity values. One is f of t minus a exists when t greater than a, and second one is 0, it is t less than a. This is the main condition of the second shifting theorem. Observe that our problem also in the same condition. G of t equal to cos of t minus pi by 3 if t greater than pi by 3, if t less than pi by 3. So the given problem g of t condition like as the statement of the second shifting theorem. That's why we using the second shifting theorem. Comparing the both statements of definition and given problem, we observe that f of t minus a in the definition, f of t minus a is our problem cos of t minus pi by 3. Comparing these two functions here, a equal to the constant value pi by 3. Removing a on both sides, remaining value of left side f of t after removing a and removing pi by 3 in right side, then cos t. So in the second shifting theorem, applying Laplace transform L of g of t, we getting the answer e power minus as into f bar of s. So we need f bar of s. How to find f bar of s? When applying L of f of t, then getting the f bar of s. Here f of t equal to cos t is available. Now I applying Laplace transform on both sides. L of f of t equal to L of cos t. We know that it has one clear formula, L of cos t equal to s by s square plus 1. Let it be named as f bar of s. So we getting f bar of s, and we know that a. So we write the statement of second shifting theorem, L of g of t equal to the final conclusion value e power minus s into f bar of s. All values are finite. So e power minus a means the constant value pi by 3 into s, and f bar of s, L of cos t, that equal to s by s square plus 1. This is the required result. Okay. This is not important. That's why I explained only one problem. Go to next definition. Today, first definition is unit step function. It is very, very important. What is the definition function? And second definition is a second shifting theorem. It is also another name. That way, second translation theorem. Second shifting theorem or second translation theorem. Yesterday topic, first shifting theorem. It has also first translation theorem. Two names are available in two theorems. So the third definition is change of scale property. This is also important on definition wise. Change of scale property definition is L of f of t equal to f bar of s. Then L of f of at, L of f of at equal to 1 by a f bar of s by a. It is also one shortcut. Easily remember it. L of f of t equal to f bar of s. This is the main condition of the Laplace transform. So in the function, there is a constant is multiple of t. Here a is a multiple of t. Then we write the opposite. Opposite means multiplication, opposite division. So 1 by a, and answer also f bar of s by a. So here in left side, a is multiple of t. We write the right side 1 by a and a division of a of s. So f bar of s, that we write 1 by a into f bar of s by a. ఇక్కడ లెఫ్ట్ సైడ్ లో ఏ అనేది కనుక మనకు మల్టిపుల్ లో ఉంటే రైట్ సైడ్ లో డివిజన్ లో రావాలి. ఇక్కడ వన్ ఫంక్షన్ ఉంటే ఇక్కడ టూ ఫంక్షన్ వస్తుంది, 1 by a f bar of s by a. సో ఈజీగా ఐడెంటిఫై చేసుకోవచ్చు. దీన్ని ఏమంటామంటే మనం change of scale property. Here another result also available. The second result is, for example, in left side a is in division position, so we write the opposite. So a into f bar of s in multiplication position. Here a is in division position in left side, then we write the multiplication position. For example, a is multiplication position in left side, we write the division in right side. So ఇక్కడ a అనేది డివిజన్ లో ఉంటే రైట్ సైడ్ లో మల్టిప్లికేషన్ లో వస్తుంది. ఒకవేళ a అనేది మల్టిప్లికేషన్ లో ఉంటే రైట్ సైడ్ అనేది డివిజన్ లో వస్తుంది. సో this property name as change of scale property. So L of f of at is equal to 1 by a f bar of s by a. And another condition, L of f of t by a. It is also written as a into f bar of s. A is in division position, we write the answer as a is multiplication. Here a is multiplication, we write in the answer a is division position. So one example is available. So the example is L of f of t equal to 9s square minus 12s plus 15 by s minus 1 whole square. Find L of 3t. Given L of f of t equal to 9s square minus 12s plus 15 by s minus 1 whole square. So find L of f of 3t. Here 3 is multiple of t. In function f, 3 is a multiple of t. Clearly, it is a condition of change of scale property. We write the opposite of right hand side. Here 3 is multiplication, then we write 1 by 3 into f bar of s by 3. First, we calculate the f bar of s. Clearly, f bar of s is given. What is the f bar of s? When we finding the L of f of t, then getting the results in terms of s, that is the f bar of s. In circulation value is f bar of s. So 9s square minus 12s plus 15 by s minus 1 whole square is a f bar of s. What is the condition of linear change of scale property? L of f of at. Here a is a multiple of t. Then we write a is a division position 1 by a f bar of s by a. So here a is 3. So 1 by 3 f bar of s by 3. So 9 into s by 3 whole square minus 12 into s by 3 plus 15 by s by 3 minus 1 whole square. Okay. First we write 1 by 3 and replace s by 3 and simplify it. Then we getting the answer is 9 into s square minus 4s plus 5 by s minus 3 whole square. This is the example of the change of scale property. So these three are definition wise important. One is unit step function and another name is Heaviside unit step function. Unit step function or Heaviside step function. Two names in single definition, and second one is have two names. One is second shifting theorem and second one is second translation theorem. Third definition is change of scale property. These are important only definition wise. So go to next one. Laplace transform of derivatives. If f of t is a continuously functional order and f of t is locally continuous function of Laplace transform f of t is given by L of f of t equal to f bar of s, then L of f dash of t equal to s into f bar of s minus f of 0, where f bar of s equal to L of f of t. This is the condition of Laplace transform of derivative. So, what is the condition of Laplace transform derivative? If L of f of t equal to f bar of s, then applying derivative of left hand side, it is also changed as right hand side. L of f dash of t equal to s into f of f bar of s minus f of 0, s into f bar of s into f of 0. This definition is very important to finding the applications of differential equations. In the last topic, after completion of inverse Laplace transform, one very important topic is available, that is the application of Laplace transform. So apply a Laplace transform to the linear differential equation. In that in that situation, we have to use these problems. L of f dash of t equal to s into f bar of s minus f of 0, and L of f double dash of t equal to second derivative f double dash of t equal to s square into f bar of s minus s into f of 0 minus f dash of 0, something like that. So these all conditions are used in how to apply a Laplace transform to the linear differential equation. In that situation, we using the Laplace transform derivatives. Okay. Next, in problematic, the next topic is Laplace transform of integrals. Observe that Laplace transform of integrals. It is the problematic topic. So four topics we are discussed. First one is unit step function, and second one is second shifting or second translation theorem. Third one is change of scale property, and fourth one is Laplace transform of derivatives. These both are application oriented. So now problematic topic is Laplace transform of integrals. Here the condition is very important and it is easy to solve. So L of f of t equal to f bar of s, we know that L of integral 0 to t f of t dt, then we write f bar of s. How many 0 to t? See in left side 1. So we write 1 by s. లెఫ్ట్ సైడ్ ఎన్నైతే 0 టు టీ ఇంటిగ్రేషన్స్ ఉంటాయో మనకు వచ్చిన ఆన్సర్కి అన్ని ఎస్ఎల్ని డివైడ్ చేస్తే సరిపోతుంది. లాప్లాస్ ట్రాన్స్ఫార్మ్ లో వెరీ ఇంపార్టెంట్ అండ్ వెరీ ఈజీ ప్రాపర్టీ ఏదైనా ఉంది అంటే అది లాప్లాస్ ట్రాన్స్ఫార్మ్ ఆఫ్ ఇంటిగ్రల్స్. సో ఫర్ ఎగ్జాంపుల్ L of integral 0 to t, integral 0 to t, integral 0 to t, f of t, dt. So in left hand side, three integral 0 to t available. First we calculate L of f of t. So first we taking L of f of t, finding L of f of t, we getting one answer. That answer name as f bar of s. L of f of t equal to f bar of s, then getting f bar of s. Once we observe the question, how many 0 to t integrations? 1, 2, 3. 3 0 to t integrations. Then we write 3 s's. S into s into s. So now we divide s cube in f bar of s. సో ఎన్నైతే 0 టు టీ ఇంటిగ్రేషన్స్ ఉంటాయో అన్ని ఎస్ఎల్తో వచ్చిన ఆన్సర్ ఎఫ్ బార్ ఆఫ్ ఎస్ ని డివైడ్ చేయాలి. ఇట్ ఈస్ వెరీ ఈజియెస్ట్ మెథడ్. ఫస్ట్ we find out the L of f of t, then getting f bar of s. After that, we identify how many integrals with limit 0 to t. So here, 3 limits with 0 to t. Then I divide 3 s's in right side. The right side value is f bar of s. Now, f bar of s by s cube. Divide 3 s's, s into s into s. So f bar of s by s cube. ఎన్నైతే 0 to t ఇంటిగ్రేషన్స్ ఉంటాయో అన్ని ఎస్ఎల్తో వచ్చిన ఆన్సర్ డివైడ్ చేయడమే Laplace transform of integrals. Remember it. It integrations 0 to t with limits. Integration with 0 to t is only Laplace transform of integrals. 0 to s and s to infinity. These type of integrations not in Laplace transform of integrals. only with the limits 0 to t. In question, in the question, integral 0 to t is available. That condition only called as Laplace transform integrals, not in 0 to s, not in s to infinity. These type of integrations not belongs to Laplace transform of integrals. It only integral 0 to t. Okay, so we're doing some problems. The first problem is L of integral 0 to t e power minus t cos t dt. This is the question. So here three conditions. Every time we calculate or we find out in right to left. So ఎలా calculate చేయాలి? Right నుంచి left కి. So I count the finding values in question. First L of cos t number 1 and applying e power minus t number 2, then applying integral 0 t number 3. Here three conditions. First one is L of cos t. Applying the resulting answer cos t find out చేయగా వచ్చిన ఆన్సర్ కి e power minus t అప్లై చేయాలి. అంతేగాని L of cos t, L of e power minus t, L of 0 t. So this is not right. So how to calculate? So how many conditions in the given problem? Observe that here three conditions. One is cos t. First we find out L of cos t. We getting the sum answer f bar of s. Now apply L of e power minus t into cos t. So e power minus t apply to the f bar of s. Then getting an again f bar of s1. Then finally applying 0 to t. Cos t కి లాప్లాస్ అప్లై చేయగా వచ్చిన ఆన్సర్ కి e పవర్ మైనస్ t అప్లై చేయాలి. e పవర్ మైనస్ t cos t కి అప్లై చేయగా వచ్చిన ఆన్సర్ కి 0 to t ని అప్లై చేయాలి. సో అంతేగాని దేనికి దానికి ఇండివిజువల్ గా క్యాలిక్యులేట్ చేయకూడదు. L of cos t, L of e power minus t, it is not sufficient to calculate individually. So first order is cos t, second one is e power minus t, third one is 0 to t. First take L of cos t. We know that the formula of L of cos t is s by s square plus, here a value is 1 because there is no multiple of t, even always t has multiple 1. So s by s square plus 1. Now taking second condition. Now applying the second condition of cos t. So L of e power t into cos t. So what is the condition? This condition has one name. In two functions are in multiplication, in two t functions are in multiplication position, one is must be exponential term. That is called the first shifting or first translation theorem. Two t functions multiplication లో ఉండి దాంట్లో ఒకటి ఎక్స్పోనెన్షియల్ అయి ఉంటే దాన్నే మనం ఏమని కాల్ చేస్తాం? ఫస్ట్ షిఫ్టింగ్ ఆర్ ఫస్ట్ ట్రాన్స్లేషన్. What is the condition of first shifting? Replace s by s minus a or s plus a, depends on left side. Here a is the multiple of t, so here a is minus 1. So then we replace the opposite sign -1 by +1. So in applying first shifting, s by s square plus 1, replace s dash to s plus 1, then getting s plus 1 by s plus 1 whole square plus 1. Now simplify it, s plus 1 by s square plus 2s plus 2. Expand s plus 1 as a plus b whole square, 2s 1 plus 1 that equal to 2. This is the second condition applying the result. First to L of cost is s by s square plus 1, then applying e power minus t to s by s square plus 1. Now getting s plus 1 by s square plus 2s plus 2. Finally, I apply 0 to t to the resulting value. So L of integral 0 to t e power minus t cos t. The final value is apply to final result s plus 1 by s square plus 2s plus 2. Here the condition of integral 0 to t. 0 to t ఇంటిగ్రేషన్ మనకి క్వశ్చన్ లో ఉంది అంటే మిమ్మల్ని ఇంటిగ్రేషన్ చేసి లిమిట్స్ పెట్టమని కాదు. మీరు కన్ఫ్యూజ్ అయ్యి వచ్చిన ఆన్సర్ ఇంటిగ్రేషన్ చేసి దీనికి ఇంటిగ్రేషన్ చేసి లిమిట్స్ పెట్టాలని చూస్తారు. అలా చేయొద్దు. సో లాప్లాస్ ట్రాన్స్ఫార్మ్ లో కంప్లీట్ గా డిఫరెంట్ గా ఉంటుంది. సో మీరు ఏం చేయాలంటే ఫస్ట్ integral 0 to t. What is the condition of integral 0 to t? Just we write the how many integrations in left side, that number of s's are divided into right side. లెఫ్ట్ సైడ్ ఎన్నైతే 0 to t లు ఉన్నాయో కౌంట్ చేసుకొని అన్ని ఎస్లతో డివైడ్ చేయండి. సో ది రీసెంట్లీ ఆన్సర్ ఈస్ s plus 1 by s square plus 2s plus 2. Now I divide 1s. So 1 by s into s plus 1 by s square plus 2s plus 2. This is the required result. సో అంతేగాని 0 to t ఇంటిగ్రేషన్ చేసేసి వచ్చిన ఆన్సర్కి దాంట్లో లిమిట్ సబ్స్టిట్యూట్ చేయకూడదు. సో హౌ టు ఐడెంటిఫై ది ప్రాపర్టీస్? ఫస్ట్ linearity property. In t functions with the difference either plus or minus, we separate the Laplace on each and every term. That is called linearity property. And second one is two functions or three functions or multiplication. One is the exponential term. Then it is also identified by first shifting theorem. And the third problematic is Laplace transform of integrals. In the question, we observe that integral 0 to t, how many integration 0 t's are available? That number of s's are divided into right side. So 0 to t, integral 0 to t is the identification of the Laplace transform of integrals. Question లోనే ఉంది ఇంటిగ్రల్స్ అని, క్వశ్చన్ లో ఇంటిగ్రల్స్ ఉంది. సో మన డెఫినేషన్ లో కూడా Laplace transform integrals. That is the main identification. Laplace transform of integrals. In the question also integrals. So you remember that the limits only. Here 0 to t only possible, not 0 to infinity, not s to infinity. Okay. Next question. The second problem is L of integral 0 to t, again integral 0 to t, cos hat dt and dt. So observe that the given problem contains two integral 0 to t integrations. Then it is clearly Laplace transform of integrals. First we calculate the function f of t. Here f of t is cos HAT. Now I taking L of cos HAT. We know that the definition of L of cos HAT as S by S square minus S square. Now I applying the complete left hand side properties. L of 0 to integral 0 to t integral 0 to t cos HAT dt dt. Observe that in left hand side, how many integrals with 0 to t limits? Two integrals. So what we do? Two integrals in left side, two s's are divided into right side. The right side value is recently finding value s by s square minus a square. So simply we divide two s's. That means 1 by s square. S square cancel. So the resulting value is 1 by s into s square minus a square. So it is very simple property to apply the functions. How many 0 to t integrations identify? That number of s's are divided into right side. Okay. Next problem. Third problem. L of integral 0 to t integral 0 to t integral 0 to t e power minus 2t into sin 3t minus cos t into dt 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 into L of integral 0 to t integral 0 to t and integral 0 to t e power minus 2t into sin 3t minus cos t into dt dt dt. So how many integrations? Three integrations. So we close with three dt functions. So first we calculate the function of f of t. Here f of t is the circulated value e power minus 2t into sin 3t minus cos t. First we find out the e power minus 2t and sin 3t minus cos t. So taking that value L of e power minus 2t into sin 3t minus cos t. Multiplying cos 2t to two functions. So L of e power minus 2t into sin 3t minus L of e power minus 2t into cos t. So what is the property we use? It is first shifting theorem. What is the condition of first shifting theorem? In two t functions are in multiplication position, one is an exponential function, then it is called a first shifting theorem. So what is the condition of first shifting theorem? First we calculate the f of t function, L of f of t, then getting f bar of s. Now replace s by s plus a. So first I calculate the function L of f of t. Here f of t equal to sin 3t. So L of sin 3t. Directly I find out L of sin 3t means a by s square plus a square. Here a equal to 3, 3 by s square plus 3 square. Finally 3 by s square plus 9. And applying the first shifting theorem, here the quotient of t as minus 2, I write the reverse of the sign s tends to s plus 2. Go to second function. Here f of t is cos t, L of f of t, L of cos t, we know that s by s square plus the multiple of t is 1. And applying the first shifting theorem, here also there is a multiple of t is minus 2. I write the reverse plus 2, s tends to s plus 2. So replace s by s plus 2 in the above condition. 3 by s plus 2 whole square plus 9 minus s by s plus 2. So numerator also s plus 2 by s plus 2 whole square plus 1. Simplify the equation. After that we getting some result. So finally the left hand side value is L of integral 0 to t, integral 0 to t, integral 0 to t. Three integrals with limit 0 to t. Now we divide s cube into the right hand side value. So three s's are divided into the right hand side value. First we calculate this right hand side, expand s plus 2 whole square as a plus b whole square. So s square plus 4s plus 4 plus 4 plus 9 that equal to 13, and expand s plus 2 whole square in second function, s square plus 4s plus 4 plus 1 that equal to 5. In the function, the total function we have to divide s cube because the left hand side 3 integral 0 to t limits are available. We getting total function of f of t value as 3 by s square plus 4s plus 13 minus s plus 2 by s square plus 4s plus 5. The total function divided by 1. So s cube. So 1 by s cube is the final result is 1 by s cube into 3 by s square plus 4s plus 13 minus s plus 2 by s square plus 4s plus 5. This is the L of f of t. This is the f bar of s. This is the integral 0 to t in three values. So now I divide 3 s's in the right hand side. మన క్వశ్చన్ లో ఎన్ని 0 to t లు ఉన్నాయి లెఫ్ట్ సైడ్? 3 0 to t లు ఉన్నాయి ఇంటిగ్రేషన్ తో. సో ఇవి పక్కన పెట్టేసి మిగతా ఫంక్షన్ మొత్తానికి లాప్లాస్ అప్లై చేసి వచ్చిన ఆన్సర్ ఇది. ఈ ఆన్సర్ కి ఎన్ని ఎస్ఎల్ డివైడ్ చేయాలి? ఎన్ని అయితే ఇంటిగ్రేషన్స్ ఉన్నాయో లెఫ్ట్ సైడ్ అన్ని ఎస్ఎల్ తో డివైడ్ చేయాలి. సో దిస్ ఇస్ ది ఇంటిగ్రల్ ఆఫ్ లాప్లాస్ ట్రాన్స్ఫార్మ్. సో లాప్లాస్ ట్రాన్స్ఫార్మ్ ఆఫ్ ఇంటిగ్రల్ is the very easy and important property. అటెండెన్స్ తీసుకుంటాను. ఆల్ ఆఫ్ యూ రైజ్ యువర్ హ్యాండ్స్. All of you raise your hands.